Good day. It gives me enormous pleasure to introduce our keynote speaker, Dr. William Li. It's fair to say that in many ways, I owe my life to Will for reasons I'll explain shortly. But another aspect of my relationship with Will is that he has become a metaphor for me in how to be your own medical director. You see, I met Will not through medical circles, but through a professional circle of relationships in the classical music business. As it happens, Will's mom had a distinguished career teaching the piano at Carnegie Mellon University in Pittsburgh. And by coincidence, one of my close professional friends was the director of that music school. In a casual conversation, my friend Noel happened to mention to Will's mom that his friend Bruce was sick with a rare cancer. Mrs. Lee immediately said that I had to go see her son Will in Boston. This was in 2009, shortly after sorafenib had been FDA approved and in my fourth year of fighting cholangiocarcinoma. Having miraculously survived a major metastasis to my liver after being advised that I had 3 months to live, we were once again out of treatment options and desperately flailing about looking for possible treatments. Will Li, with his relentlessly positive, inventive, and out-of-the-box thinking, worked closely with the developer of targeted therapies, Dr. Juna Folkman, at the Dana-Farber Institute. Will gave up his medical practice to create the Angiogenesis Foundation in 1994 to further Folkman's work, and through the foundation has systematically explored secondary and tertiary uses of drugs, as well as deep research into the relationship between what we eat and the diseases that we develop. Will told me that sorafenib on its own likely wouldn't help in my case. It had already failed in cholangiocarcinoma trials. But if we combined it with Celebrex, celecoxib is the generic name, it might work. When I took this information back to Greg Gores at the Mayo Clinic, he said, "I don't know quite why, but there's something to that. Let's try it." And we did. I'm still on that combinatorial therapy 11 years later. My experience with Will Li is one just very narrow slice of his broad scientific inquiry into how diseases work. From the extraordinary bench research he leads at the foundation, to his TED Talk, Can We Eat to Starve Cancer?, to his newest bestseller, Eat to Beat Disease, to his humanitarian efforts to help people lead healthier lives, Will Li is an extraordinary leader in our field, working alongside the clinical and research communities to make our lives better. It's an enormous honor to welcome my friend and lifesaver, Dr. William Li.
It's a pleasure to be here. I'm going to speak about dietary modification of the tumor microenvironment, and want to start by reflecting on how far we've come in oncology from the days where we simply looked at the cancer cell as the target, and where we went from chemotherapy to so-called targeted therapies, thinking that we could be smarter than the tumor by aiming at very specific signaling pathways. And that was really the breakthrough of the 1980s and early 1990s that I took part of, and it was very exciting days until we really had a much more comprehensive view of the tumor microenvironment, realizing that it really is a short-sighted but meaningful attempt for us to hit individual targets when, in point of fact, cancer is so much more complex. So in today's world, we're really looking at how to actually tackle this complex tumor microenvironment for cholangiocarcinomas and other cancers. And I think that for cholangiocarcinoma, there's a lot that we can learn from other tumor types as well. Because indeed, we're beginning to move from the organ-specific designation of cancer in terms of therapy to think more broadly in terms of how does the body actually naturally resist cancer, and what are the elements of the microenvironment that could be useful to prompt or activate. And again, in addition to the cancer cell, we've got the vasculature, which I'm going to talk about. We've got extracellular matrix components, immune cells, and other coagulative properties conferred by the circulation and blood cells as well. So one of the most innovative ways of addressing the tumor microenvironment is, in fact, the simplest and the most complex at the same time, and that's really nutrition. And although this is not an area that has been in the mainstream of oncology, I'm going to try to make a case for you how molecular nutrition and nutritional oncology is going to be one of the future pathways opening up in cancer medicine. To begin with, I'll just introduce to you this old quote attributed to Hippocrates, said, "Let food be thy medicine." And we know that food is so important for so many other dimensions within our physiology. And so why wouldn't it actually also activate our health defense systems? Well, nutrition itself has largely been viewed as a immature science compared to pharmacology or pharmaceuticals, especially in oncology. But increasingly there's data, some of which I'm going to show you, to support the fact that, in fact, nutrients and whole foods can actually have an impact on patient outcomes. And it's not just a few renegade doctors, who have left classical medicine, pharmaceutical, prescription medicine, that have gone on to do soapboxing about the kale, for example. And in fact, I'm not one of those people. I have been and actively still am involved with drug development, everything from targeted therapies to immunotherapies. And it's not just those of us that are sort of on the vanguard of looking at the role of nutrition, but in fact, 2,000 years later, after Hippocrates, state plans are beginning to look at food as medicine. And not just the state, but in fact, insurance companies, payers are beginning to embrace the idea as well. This is actually from a billboard from Blue Cross Blue Shield in Minnesota. And even Capitol Hill, there's a bipartisan committee called the Food as Medicine Working Group that's been convened to begin taking a look at that. And while this was convened before COVID, in the COVID era, the role of food and its impact on health becomes even more impactful, and I can anticipate there'll be even more investment at the federal level into this. And not just at the federal level, but even at the level of the leaders of faith in the Vatican. This is from a conference that I took part in a few years ago, examining the convergence of science for curing diseases in humanity, improving humanity. And one of the topics was utilizing diet to mobilize our health defenses against disease and against harms caused by the environment. So again, this is no longer just sort of what you find on the internet, but really a movement that's starting to take place, and it's going to impact on the workers in oncology, from patients, caregivers, nutritionists, physicians, oncologists, oncology specialists, people who are working in drug development, nutrition development as well. Regulators are also beginning to take a look at this. The most important part of taking a look at food as medicine is, what is the evidence? And that's really what separates the serious efforts in advancing oncology from those that would be considered alternative medicine. And what I'm going to present to you is really scientific evidence in this field. But we do need to actually acknowledge that if you were to go on Amazon, for example, go onto the internet, it is very easy to find, thousands, tens of thousands of products that are claiming all kinds of things, books, dietary supplements, claims for cures that are out there. And no wonder patients are confused, and no wonder the healthcare system has actually gotten kind of skeptical and cynical about what's gone on outside of our own healthcare establishment when it comes to food as medicine, nutrition, guidebooks, etc. And if you consider the fact that virtually anybody can start a dietary supplement and within a few weeks put it on the internet, it's important to recognize why we actually use evidence so rigorously, which is that when it comes to drugs, it can take up to 10 years, more than $1 billion, $2 billion at the latest estimate, in order to bring a drug through all these steps, from basic research to preclinical studies to clinical trials, phase 1, 2, and 3, and then critically reviewed by the FDA before a drug can even get to market for a very narrow indication. That's its strength, but it's also its limitation, because our dependency on the randomized controlled trial actually limits, almost shackles us, handcuffs us to only a few interventions that are painstakingly arrived at over a long period of time. And indeed, even the idea of the randomized controlled trial as a gold standard for us is quite limited. RCTs really generally talk about a drug intervention or medical technology intervention that leads to a mean and average improvement of a disease endpoint that's selected before the study, and you compare the intervention to a control over a relatively short period of time, months perhaps, or even less, and under highly controlled conditions, sometimes not even seen in the real world. And at the end of all of that, the only acceptable answer is a yes or a no, and it relies on the statistical p-value to be less than 0.05. So this is a pretty big filter to actually prove that something works or doesn't work. And it's a tall order that nutrition is very difficult to actually put through. And so this is another reason why the evidence on food as medicine needs to actually be reconsidered for how do we actually calculate what we find in the marketplace, in the kitchen, what patients can do for themselves without a prescription at their homes instead of the doctor's visit or in the infusion clinic can actually mean for them. So in reconceptualizing the burden of evidence for food as medicine, one of the things that we're working on is looking beyond clinical trials alone and looking at the genomic and molecular evidence by looking at in vitro, cellular, ex vivo, outside of the body, in vivo, and animal models, biomarker studies both in the animals and in humans, of course clinical trials of various sizes and various designs, and population studies, which, you know, in the case of drugs is now sometimes called real-world evidence. And I think by looking at the totality of this evidence, we're beginning to be able to get our arms around food in a more comprehensive way, perhaps even more comprehensive than we traditionally evaluate drugs. And it frees us from simply relying on the randomized controlled trial, although that still becomes a gold standard for us to look at evidence. So I want to show you an example of a study assay system used in the lab for studying blood vessel growth, because we know that tumors require blood vessels, tumor angiogenesis, in order to be able to grow and spread. And on the left-hand side, you see this ring. This is sort of the eagle's eye view of a aorta of an animal in a cancer research lab. So think about it as a calamari ring. You take the biggest vessel in the body, the aorta, you cut it into rings, 1 millimeter section, and you put it into a dish with gelatin and feed it with broth that helps cells grow. And the endothelial cells, the blood vessel cells that are living inside that aorta, inside that calamari ring, will respond to the growth factors in the medium, and when they start growing, they'll explode out in a sunburst-like fashion. So those white lines are all the blood vessels that have grown out. And when you expose this system to a drug, for example, some of the anti-vascular drugs, anti-angiogenic drugs that have been FDA approved, and I was involved with helping to develop this system, you can kind of see, you can shrink back those blood vessels, in essence, starving a cancer by cutting off its blood supply. This is one of the targeted approaches to cancer therapy. Now, what's really interesting is that a few years ago, my group actually compared that system by looking at drugs, and here you can kind of see the healthy starburst in the black bar from left to right. And then we tested various drugs, cancer drugs in blue lines, and even common drugs, off-label repurposed drugs in yellow. And you can kind of see that there are cancer drugs like lenalidomide used for multiple myeloma, tamoxifen and Paxil used for a wide variety of cancers, irinotecan also used for a wide variety of tumors. And they actually can start to cut down on the vascular growth that you would see in this aortic ring model I just showed you. And surprisingly, or maybe not surprisingly, some of the drugs in a medicine cabinet that are common drugs like blood pressure medicines like captopril, the statins, or antibiotics, or COX-2 inhibitors, the anti-inflammatory drugs, can also have activity as well. This, by the way, does speak to the opportunities to repurpose drugs, which is obviously going on in the COVID-19 era, where people are beginning to take a look at what's already been approved and finding activities that could be useful for treating diseases that might not be able to wait for a decade, like COVID-19. And that's how dexamethasone and even remdesivir actually went back to kind of pull something out of the closet to see if it might actually have a beneficial effect. And so in oncology, this has been done for many, many years. And this system just shows you, if you can take a look at new drugs and old drugs, you can actually see what their effects on angiogenesis, for example. But my group actually compared the effects of drugs head-to-head, side-to-side with foods. And this is, an eye-opening result that we actually found that in many cases, you can actually take foods like soy, berry, parsleys, garlic, lavender, green tea, and you can actually see that, at least in this drug development system, you can actually get activity that is, in some cases, equal to or even more potent than the effect of a drug. So obviously, this is an experimental system. It's not tested in human clinical trials, but it actually does open our mind to the fact that foods and their extracts can actually have potent pharmacological activity in the same assays from which we develop drugs. And again, this is a summary that I've shown before. In fact, at the Vatican meeting, showing the food on the left, the bioactives that are present in the food. These are natural chemicals. The dosing that's been found and the clinical outcome in population-based studies. So when you start combining some of the laboratory studies with the population studies, that's kind of a bookends that allow you to dive further to be able to do more careful research. But I want to emphasize it's not really just about the food, because there are no superfoods or magic foods, but it's really about how our body responds to food, much in the same way that that's how our body responds to the pharmacology that we might use, or cancer drugs. And what's really new about the food as medicine movement has really torn a page from the playbook of pharmaceutical medicine, which is to think about the body as hardwired with systems and pathways that respond to what we put inside it. So I want you to think about it as a fortress, and most people have seen a fortress or a castle, and whether you've gone to Europe and actually seen an actual castle, or you've gone to Disney, taking your kids there to see the Magic Kingdom, everybody recognizes the turrets and the walls and the moats. But if you actually take a look at the anatomy of a fortress, of a castle, you'll see that there's many different ways that the designers of a fortress have put into place systems that actually can foil invasion. So the moat, the arrow slits you're probably familiar with. The talus is the sloping wall that prevent people from just climbing up. But many people don't know about the spiral staircase that was actually designed. If you take a look at the staircase, in every single case, the staircase is built clockwise, and that allows people who are defending the castle from the top, from the fortress, who are mostly right-handed, to be able to strike downwards, where it puts the enemy coming up from the bottom. If they were right-handed, they would actually not be able to swing upwards as effectively. So again, it's design, defense by design. Many people might not know what a trou de loup is, but that's basically a tiger trap put on the grounds of the castle. And a murder hole is something that most people visiting a castle as a tourist won't have gone in through the entrance where you get your tickets and looked up to the top and realized that, in fact, there's actually a hole that people would drop boulders or pour boiling oil on against the enemy. So historical kind of note, but just to say that our body is designed with similar defense systems. And I just want to share with you 5 of them that are important in oncology for cancer, patients with cholangiocarcinoma and other tumors. Angiogenesis, controlling and preventing blood vessels from feeding our cancer, but feeding good cells. Regeneration, our stem cells, our microbiome, our gut bacteria, our DNA's ability to protect itself from mutations and from aging and from other assaults from the environment, damage from the environment, and also, of course, our immune system, which we know from immunotherapy of cancer, which I'll talk about briefly, but also immunity in the era of COVID becomes really, really important. We've had a kind of newfound look at these defenses to be able to understand how our body is able to resist and overcome the vulnerabilities that we have both to problems, pathology inside our body like cancer, but also outside of our body, such as environmental insults, harmful exposures, and also viruses as well. So I want to use this as a template to talk about how food can actually be used as medicine. We'll start with angiogenesis. Blood vessels are normally important for bringing oxygen and nutrients to all the parts of the body, but tumors are able to hijack the growth of blood vessels to feed themselves selfishly. So they're able to get their own private blood supply. And one of the big breakthroughs of modern oncology has been to install, in addition to chemotherapy and radiation and surgery, targeted therapies, one group of which can target the blood vessels feeding cancer, and those are anti-angiogenic therapy. And there's more than a dozen drugs that have been FDA approved for use there. And most of them have actually been run through this old system I showed you just a little bit earlier, the aortic ring model. And remember, this is what happens when the blood vessels see the growth factors that tumors and other things can release, inflammation, and they'll explode in a starburst of blood vessels. So literally you can inject one of those white tubes and with ink, and the ink will flow all through it. But when you actually test it with food, remember I showed you that head-to-head study, take a look at what happens when you actually use an extract from soy and you get genistein. You can almost completely shut down this, and this is actually much more potent than some of the anti-angiogenic drugs that I was involved with developing as well. And so you might say, well, wait a minute, soy and cancer, we know that soy has been heralded as harmful to women, for example, with cancer, with breast cancer because of the phytoestrogens. These are plant-based estrogens. And the question is that really true? It turns out that human estrogen actually doesn't really look like soy estrogen, and vice versa. If you take a look, just compare the molecular ring structure, you can see both ends of this molecule are very different. And the center actually also looks different as well. And so it turns out that phytoestrogens, plant estrogens, in fact, block human estrogens for the most part. And then the real question is this true in people? It turns out it is actually true. They're not the same, and that soy intake actually can improve breast cancer survival. This is from the Shanghai Women's Health Study, looking at 5,042 breast cancer survivors. So these are women who already have had breast cancer, a highest risk group. And it was shown that those who had the highest soy levels of soy intake had about a 30% reduced risk of death and a 30% reduced risk of recurrence as well. And the dose of soy was about 10 grams of soy protein a day. That's about the amount you'd find in 1 glass of soy milk. So achievable doses in a real world setting in the highest risk group. So this was published in JAMA in 2009. And the question is, that's one study. How do we know it's true? Well, here's 14 studies in which you actually take a look at death versus survival. And in every single case of these studies, and some of these are clinical trials, interventional trials, you can see that the consumption of soy was associated with improvement in survival, and in no cases that actually associated with increase in death. So again, this is the way that those of us working in food as medicine are beginning to think about the role in oncology and how we need to begin making bridges between what traditionally has been seen as nutrition and into mainstream medicine, because the missing tool in the toolbox, I think, in oncology, in addition to all the drugs that still need to be developed, is the tool of nutrition as well. Tomatoes is another food that actually contains a number of different bioactives, including lycopene, and lycopene inhibits angiogenesis in that assay that I showed you, the aortic ring. And the health professional follow-up study of 46,000 men showed that those who consumed 2 to 3 servings of cooked tomatoes a week had a reduced risk of developing prostate cancer by 30%. And what's interesting is even those who did develop prostate cancer, when you did the biopsy of the cancer, showed that those who had more tomatoes, cooked tomatoes, tomato sauce, each month had a bigger reduction in tumor blood vessel area, so reduction in tumor angiogenesis and normalization of blood vessels as well, which actually is also a reflection of a reduction of the impact of the growth factors on the vascular system. So these are the same principles that we actually look at anti-angiogenic therapy. And in fact, the lycopene, which is normally relatively inaccessible if you eat a raw tomato, is amplified by cooking. Remember, I told you that data comes from men eating cooked tomatoes. And it turns out that cooking tomatoes increases the bioavailability of lycopene by 50% at 2 minutes and by 250% at 30 minutes. So think about simmering tomatoes in tomato sauce. And because lycopene is fat soluble, it's a fat soluble substance, when you actually simmer it with olive oil, it actually makes it more bioavailability in your bloodstream. So now think about the Mediterranean diet. So again, we're kind of beginning to reconsider the role that nutrition has with the cultures that many of the healthy dietary patterns have had, with what the impact might be on the molecular level. And the highest levels of lycopene in tomatoes can be seen here in different types of tomatoes. When you go to the market and you're wondering which tomatoes you should buy, in the future, I think we're going to be taking a look at which are the highest lycopene levels when we're thinking about giving advice to some of the cancer patients as more evidence rolls in. So this is a partial list of foods with anti-angiogenic activity. You don't have to try to copy it all down or get a screenshot. I actually wrote a whole book with more than 200 different foods that was published last year called Eat to Beat Disease, and that contains a lot of these foods as well as the evidence, mostly human evidence that I put in, that also talks about the dose and how the study was designed, along with 700 references in it. I want to talk a little bit about regeneration because stem cells are important, and we now know that humans actually do regenerate from the inside out very slowly in comparison to what a starfish or a salamander can do, but that these stem cells that lead to regeneration are called into action after injury. So surgical oncology, when you make an incision, remove a tumor, part of the wound healing that occurs and part of the rebuild of organs that actually have had tumors resected from involve the recruitment of stem cells. And the greater the injury, and this is from a burn patient study in Italy, the greater the injury, the more stem cells respond. And you can detect these stem cells actually in the bloodstream and the circulation as well. We also know that during aging, about 50% of our stem cell activity is actually lost, as from the time we're young, which is when we're fully loaded with stem cells, until we age. We lose our ability to heal, which is why elderly people tend to have slower wound healing. But and there's a number of different conditions, health conditions, where stem cells, with their deficiencies, seem to play a role, and this is where regenerative medicine comes into play, trying to rebuild organs. Now, why is this important actually in oncology? Well, because diet also plays a role to enhance stem cells. There are some dietary patterns that can enhance stem cells. So think about where you might recommend to a patient who's had surgery, like a Whipple procedure, to help to rebuild their system and to heal wounds. And there are dietary patterns that can harm stem cells, and some of those dietary patterns are the same ones we know aren't very healthy for you to begin with: high fat, high salt, hyperglycemia. So this is another reason to actually be able to advise patients on what to be careful after they actually have a big surgery like a Whipple. And in fact, some really interesting studies show that cacao, chocolate, actually can immobilize stem cells themselves. This is actually a cardiovascular study looking at baseline stem cells, and 30 days later, if people drank 2 cups of hot cocoa with dark chocolate, essentially high flavanol chocolate, so think of 80% cacao or greater, you can actually see up to 2-fold magnification of stem cells from baseline. And so, again, this is not a recommendation or prescription, but actually an interesting finding in a relatively small number of patients, but it also makes us think about the role of stem cells in wound healing, for example. But not all stem cells are good for you. Some stem cells are bad, like cancer stem cells. And the question is, how do you get rid of cancer stem cells? Because these are the cells from which tumor recurrences tend to come back. They drive the recurrence of cancer. And it turns out there are some foods that are also been shown to kill cancer stem cells. Remarkably, cacao, chocolate, purple potato actually has been shown to actually kill colorectal cancer stem cells. Elements of green tea and as well. Walnut polyphenols also have been shown to actually have a cancer stem cell killing effect. Olive oil and even capers. Chlorogenic acid is one of the bioactives in capers that also kills cancer stem cells. So again, something that's eluded drug discovery, which is something to kill cancer stem cells, may already be available to leverage and to do more further research on in our food system. Something to think about for future research activities. I want to close by talking about the microbiome and the immune system, because they're linked together, our healthy gut bacteria and our immunity. And we know how immunity is important for preventing cancer from occurring, because our immune system is really a group of super soldiers in our body, or immune super soldiers that patrol and can recognize when cancer cells are around and eliminate them, which is why we probably don't have clinical cancer more often, and yet we're forming microscopic cancers all the time. This led to the 2008 Nobel Prize to Jim Allison and Tasuku Honjo for their pioneering work in developing the basis and discovering the basis for immunotherapy for cancer. One of the most famous beneficiaries is our former President Jimmy Carter, who actually had metastatic melanoma to his liver and his brain, and he actually had a dramatic early response where he was actually able to eliminate all signs of metastatic cancer, even in the brain. So think about how difficult it is to get drugs across the blood-brain barrier. This is not a drug, and this is not killing the cancer cell. This is actually using the immune system, uncloak the cancer, to actually get in there and actually to destroy the tumor using the endogenous mechanism. And of course, that's not the only way that immunotherapeutics work, but for the checkpoint inhibitors, it's one of the critical approaches. So this has also started to affect how we think about cholangiocarcinoma. There's quite a lot of work looking at immunotherapy for cholangiocarcinoma. I just wanted to point out that it may not be as straightforward as we think, because not all cholangiocarcinomas express the targets that have been associated with immunotherapeutic response, like PD-L1. And so many oncologists have said, well, that's not going to make you a candidate then. But here's an interesting case to show you it's not so straightforward, that PD-L1 can be negative, but you can actually somehow still prime cancer patients, in this case with stereotactic beam radiation, which might expose more epitopes, and then add checkpoint inhibitors to it. So this is an abscopal response, clearly not the mainstream on-label way of doing this, but it's a case report that's actually worth paying attention to for patients who are really thinking about, well, what can I do? What's the evidence out there that we can actually move forward with immunotherapy, even with checkpoint inhibitors? So, and because we're beginning to take a look beyond simply the single targets on cancers again, when it comes to immune therapy, what's really complicated is that we're understanding that there's a social network. Think about a Facebook group that chats between our immune cells and our non-immune cells. And one of the most important chat groups is between our microbiome and our immune system, because we now know about 70% of our immune system actually lives within the lining of our intestines. And living just on the inside face of that lining, in fact, is our microbiome, our gut microbiome. And it turns out that work by Laurent Zitvogel and others in Paris have now begun showing this pretty powerful effect between the gut microbiome and talking to our immune system, and actually potentiating the effect of checkpoint inhibitors and other immunotherapies. And one of the things that we realize is that there's in responders versus non-responders to immunotherapy, there's been at least one gut bacteria that stood out that is present in the microbiome of responders, and that's Akkermansia mucinophila. And this was presented at the European Society of Oncology. And this Akkermansia mucinophila is a natural bacteria. You can't eat it as a probiotic, but it actually naturally grows in the mucinophila of the gut. And foods like pomegranate can actually induce the gut cells to actually secrete more mucin, which then grows more bacteria. And the way that it actually works is really by increasing pomegranate, the elijah tannins increases gut mucus secretion, which then grows more Akkermansia. As the Akkermansia grow, they have that social network conversation with the immune system, which then releases and amplifies a whole host of immune cells. Now, these immune cells actually are really important for immunotherapy, because when you hang a bag of immunotherapy, cancer immunotherapy, the pharmacology relies on our immune system to be able to actually do its job, to be able to tackle and dismantle the cancer cells. And the reason I know about this and why I'm pointing it out to you, because it had a really personal nature to me. My 83-year-old mother had endometrial cancer had surgery and a recurrence about a year after surgery, and had spread, had metastatic disease following. And the sort of the traditional way of looking at the outlook was really bad, but we actually wanted to actually optimize her immune system and optimize her microenvironment. So we actually gave her pomegranate juice, lagertanus, as well as immunotherapy based on the evidence that was available thus far. We also combined a little bit of SBRT, that's stereotactic beam radiation. And about 7 weeks later, after we started the therapy, she had a complete response. And so again, this is a personal victory for me. And it just shows you that we really just can't accept the fact that yesteryear's limitations of what we can achieve with cancer, really needs to be reconsidered as we push the bar forward, not only with immunotherapy, but with nutritional oncology, and as our understanding of the gut microbiome actually improves as well. I want to show you, and just by closing, another couple of interesting findings, particularly in the era of COVID. This is a study of broccoli sprouts, which are 3 to 4 day old broccoli plants. They're tiny little things, so you have to kind of cut them with a pair of scissors, and you can sprinkle them on a salad or turn them into a shake. This was the study out of North Carolina, where they were looking at young, healthy people, college-age people who were going to get a flu vaccine, in this case a nasal flu vaccine with partially killed flu virus, influenza virus. And they divided the group into 2 groups, where one group received a placebo drink, a shake, and the other group got a shake made with 2 cups of broccoli sprouts that are pureed into the shake. Now, what is in broccoli sprouts? Well, there is a natural bioactive called isothiocyanins, sulforaphanes. These are the things that actually give broccoli, for example, its very characteristic taste and flavor. And you can just puree those into a blender and made them into a smoothie. And then they gave them to the subjects and then measured their immune responses. And here's what they actually found. They found in the sprout eaters that they had 22 times more natural killer T cells as a response compared to the patients on the placebo. That's pretty important, because those natural killer T cells are what the flu vaccine was dependent upon. And when they actually isolated those T cells and looked at them in a lab, the NK cells had more killing power against virus as well. And compared to the placebo group, when they look at the placebo group, the sprout eaters had fewer virus particles left in their noses as well, so better virus clearing. So you can imagine how this type of research opens the mind of people that are actually thinking about the nutritional interventions that might be possible for amplifying a COVID-19 vaccine. And so this is an area of research that's going on as well. But think about this as also potential for amplifying the effects of immunotherapy also. So most cancer patients that I've ever worked with always have a question: how bad is it? How long do I have? What kind of treatments are available? Of course, also bringing in a whole pack of information they've printed off the internet. And then they also ask, what should I eat? And most oncologists haven't been trained. Most doctors haven't been trained in nutrition, sort of the molecular nutrition that I'm talking about. But I think that's going to change in the years and decades to come, because this kind of data is really telling us that there may be new tools in a toolbox that really need to be part of the mainstream of our teaching and training and education and clinical care. It's early days yet, and I'm pointing that out specifically. The food as medicine is really just the gateway is just starting to open, but the same serious ways that we're actually looking at biomarkers like immune markers, and the ways that we're looking at this in the lab and in the clinic and designing studies are beginning to generate some of the evidence that we should be taking these things more seriously. And by the way, I just showed you an example with the checkpoint inhibitors with the flu vaccine, not food versus medicine. I strongly believe that we're going to continue to innovate and develop even better treatments, pharmacology, to build on top of the existing repertoire of pharmacology that we have in cancer. But food could be combined. with medicine, and that's an important concept. It's, anybody who tells you that you can substitute medicine and swap out food really isn't taking the totality of what the opportunity is and taking a stance against medicine, and that's not what I believe in. Here's a study from 2017 looking at human cholangiocarcinoma, and actually shows that sulforaphanes, remember I told you about sulforaphanes being the bioactive in broccoli sprouts, actually sensitizes the human cholangiocarcinoma cells to cisplatin. And what it does is it actually downregulates the survival proteins that the cholangiocarcinoma cells need. So again, this is the lab study, but again, it actually just starts to put together another piece in this 1,000-piece jigsaw puzzle that we're trying to solve. And it opens some doors to ask, well, what might be the role in adding food and thinking about how to design the impact of food, and beginning also to ask, what are patients eating in our clinical trials? And that could actually affect the impact of the results of our clinical trials. And here's actually a study from Thailand, Northeast Thailand, where the incidence of cholangiocarcinoma is actually very high, where they did a population-based study and looking at fruits and vegetable consumption. And again, this is actually kind of a public health study. It has lots of limitations. It's not cause and effect. It's association, but you can actually see the association of having a healthier diet with more plant-based foods. Fruits and vegetables actually was associated with a reduced overall risk for cholangiocarcinoma with the highest intake of fruits and vegetables. So again, I think there's a lot to be learned, a lot more research to be done, but really I think an important new avenue to fund research, to get investigators around, and actually to build them and bake them into the trials that are already going on. And the other day I took a look at clinicaltrials.gov to see if there are any dietary studies for cholangiocarcinoma. And right now, there are only 2 studies that are in planning or just starting to recruit. And by the way, this is a very small number of studies, and they're being done in Poland and in Quebec. So I think that what this means is that there's a huge opportunity for other people around the world who are serious scientists, medical researchers, oncology investigators to really get behind the food as medicine movement. We can't only rely on our pharmaceutical companies to be able to come up with targeted therapies or immunotherapies. We also need to be able to look at the fact that the patients are making daily decisions on foods that can impact their health defenses and could impact on the ability for the pharmacology to actually have the desired effect against cancer, and could potentially amplify the benefits that we're looking for, or potentially take away from those benefits as well. The work in the food world is even going deeper. This is called the flavorome. So you've heard about, the human kinome, looking at pathways. Flavorome is what the food researchers are bringing into it. They're taking a look at the different bioactors that are found in different types of foods and looking at how they're interconnected and seeing what the pathways that they share are within the food group, and then combining it to think about how do they actually fit into humans as well. So I think within the next few years, and definitely over the next decade or so, we're going to be seeing a transformation from the pharmaceutical-only approach that we have to cholangiocarcinoma to being able to broaden our thinking into what the impact of the choices that patients are making at home, and the advice that they're looking for, they're seeking, and what we can actually give them. Not just eat whatever you want, just to make sure you don't lose too much weight, or go ahead, you should just enjoy yourself, and not just only prescription or medical foods, but to really think about the impact of the variety of foods that are actually that the patients are actually taking into that can affect the tumor microenvironment. So I'll just close with this quote by the philosopher Albert Szent-Györgyi, who won the Nobel Prize in 1937, the physiologist. He actually said, "Discovery consists of seeing what everybody has seen and thinking what nobody has thought." I hope what I've shown you today lets you appreciate the type of reboot that nutrition is actually undergoing, and what happens when you take a drug development approach to thinking about the foods that we eat and the impact that they can actually have on our body's physiological defenses against pathology, including cancer, specifically cholangiocarcinoma. So I'm looking forward to a lot of transformations and innovations that are going to happen in this space, and hope to bring you updates as it relates to cholangiocarcinoma in the future. Hi, this is Dr. Will Lee, and I'm actually coming to you live from Massachusetts, and hope you enjoyed the presentation. I'm looking at a ton of questions that actually come through, and I'll try to answer as many as I can. Some of the questions that came through related to individual food elements related to cholangiocarcinoma, including turmeric and curcumin, which I will tell you is mostly in the laboratory setting that curcumin has been studied in the context of gastrointestinal tumors, including cholangiocarcinoma, and there are specific pathways that have been implicated in how turmeric would work against it. I'm not aware of any clinical studies that have been done just yet, but I think it's really interesting to think about how long curcumin and turmeric has been used, for example, in Ayurvedic medicine, which is an alternative approach, alternative philosophy, really, to treating disease. I think this is sort of fertile ground for studying in the future. Another question that came up were foods to avoid with cholangiocarcinoma, and I would say this is sort of generally true for cancer patients as a general rule, but probably for most people, even when they're not battling cancer, which is try to avoid added sugar, try to avoid excess intake of meat, avoid processed meats. That's actually labeled as a carcinogen, considered a carcinogen, processed meats by the World Health Organization. And try to avoid ultra-processed foods, which often contain a lot of chemicals that are not really well characterized in terms of what the effects are in someone who actually has cancer. Most chemicals in processed foods have been studied by regulatory authorities to be acceptable in levels in healthy animals. So that's a very different situation than we have. I think what's really clear is that when you actually have cancer, your body's health defense systems can be negatively influenced. For example, we know how important our immune system can be to help us combat cancer, and we know our microbiome communicates with our immune system, and we know that there are certain foods like sodas, processed meats, some types of ultra processed meats and ultra processed foods. And by the way, also artificial sweeteners have been actually shown to alter the microbiome. And so those are some examples of foods that probably should be avoided if you can. Now, antibiotics obviously will change your microbiome. So then the question is, if you have to be on antibiotics, which many people with cholangiocarcinoma will have to take antibiotics at some point in their management of their disease, what would you do to actually try to restore your microbiome? So this is where we're really at the beginning of this new frontier of understanding the microbiome. Some concrete, practical answers are try to have some fermented foods like kimchi, sauerkraut, yogurt. Those actually tend to have healthy bacteria that can contribute to influencing the ecosystem of the gut and try to restore health. We also know there's probiotics that you can actually take. A question I always get asked is, is there, a superior probiotic? And I don't know of a single probiotic brand that actually covers everything we need. In fact, we're not really 100% sure how taking a probiotic actually changes the neighborhood, the ecosystem of our gut. But we do believe that it actually can make a difference. So try to avoid things that harm your gut microbiome. Try to add things to your diet that actually benefit it. Those are pretty good recommendations. There's another question about plant-based foods. And, like so many things that relate to nutrition, one of the things that has happened with the whole plant-based food movement is really turning it into a slogan or into a food fad. And what I would tell you, as sort of the science guy, the medical researcher, the person who's actually involved with drug discovery, drug development, and also taking a look at food as medicine, is that there are no magic bullets, there are no superfoods that are out there. However, the data in almost every single case, when it's been looked at, has shown that diets that are composed of mostly plant-based foods tend to be associated with better health defense systems, better disease outcomes, and then, usually when you eat more plants, you're eating less animal protein as well. I am not a vegan or a vegetarian, although I think that people who choose that are making deliberate choices that are going to also help their health. But if you do actually eat meat, just recognize that the less you eat, the better it is for you. Another question came on about keto, the ketogenesis diet, intermittent fasting, caloric restriction. I get to ask this a lot, in the public from people who don't have cancer and are thinking about other things like their beach body or, some other health-seeking population community. I will tell you, for cancer, what's really interesting is the research is starting to show that caloric restriction does influence the microenvironment of the cancer. I don't know how much has been studied for cholangiocarcinoma patients specifically, but broadly speaking, lowering calories actually alters the metabolism of the microenvironment around cancer cells. We do know that when you do intermittent fasting, one interesting thing that happens is that you help to reboot your microbiome, so that we know that that's probably helpful. So when you undergo intermittent fasting, bad bacteria tend to die off and good bacteria tend to grow back in. We also know that the stem cells in your gut, remember the stem cells are where the gut is, where the immune system is, that the stem cells for immune cells also tend to be rebooted during intermittent fasting. So old immune cells that have worn out tend to be tossed out, kind of put in the trash and deleted, and new stem cells tend to repopulate and grow. Now, this has been studied in humans as well, and that's really, really interesting. As far as ketogenesis, this has been best studied in the medical setting for pediatric patients with uncontrollable seizures or epilepsy. And ketogenesis does seem to influence the brain. And for that reason, it's also been studied in glioblastoma, which is a brain tumor. And while, that is a really, really difficult cancer to actually manage, I would say almost as difficult or about the same as cholangiocarcinoma or pancreatic cancer. It's one of those, really aspirational cancers where we really need better treatments for them. In brain tumors, you actually do get some modification of disease with a ketogenic diet. Now, what I will tell you is that the ketogenic diet is not considered to be a healthy diet. It's really difficult, impossible to maintain for a long period of time. So what I wrote about in my book, Eat to Beat Disease, is more than 200 foods that allow you, and the principles behind them, that allow you to actually lean into your diet to select the foods that you enjoy eating, that activate your defenses, that actually can target angiogenesis, target cancer stem cells, help to improve your gut microbiome, modify the DNA, protect your DNA in your body, and also help to enhance immunity. And that's really the basis of one big arc of food as medicine research. Let's see. Other things that I've been asked, I'm trying to cover as many as I can. Somebody asked about cookbooks for cancer patients. I think if you take a look at all the foods that I've actually included in my book, if you can find, whether it's a cookbook or whether you find something online that can actually guide you in actually cooking something or having somebody help you prepare something that you enjoy eating, I think that would be an important thing to do. And then, back to another question about testing the gut microbiome. There's a lot of companies out there that are offering gut microbiome tests. I can tell you that we're not really ready for precision nutrition, precision gut microbiome cancer matching consumer test yet. But if you wanted to actually measure your gut microbiome, one thing that you should just look for are the population, when the results come back, if there are lots of bacteria, and it should be in the results, that show that they are harmful bacteria. More bad guys than good guys. You could probably bet that the immune system in your gut has been compromised by the bad bacteria. So, the goal is probably to try to get more physiological, homeostatic, good neighbors, good healthy gut ecosystem. I don't recommend fecal transplants. I don't think we have enough information on that yet, even for inflammatory bowel disease. And that, that's a very specific type of procedure that's actually frankly invasive. I think in the future that will play a role, and I think that's going to be a huge, interesting a future direction. Is there a population of gut flora or a fecal bacteria that we can put into a cancer patient to help augment cancer therapies? That could be really, really very interesting. Let's see if anything else that I have there. I get all this question about alkaline water. I can tell you the human bloodstream is designed to be the perfect pH at all times. It's very difficult to actually eat anything that would make your blood more acidic or more alkaline. In fact, if you tried to, you probably couldn't. And when your blood actually becomes more acidic or more alkaline, it's usually that you're on your way to dying. Like that's usually what we see in the intensive care unit when somebody is septic and bacteria have completely overtaken the body. So I don't put a lot of stake in that. Although, what would be interesting is to take a look at the pH of your gut, and that's something that people who are studying the gut bacteria in a microbiome are also doing. Food is not the only answer, for sure. Many other things are partners to how our body's defenses actually can help us combat and overcome cancer. Because don't forget, when people ask, well, why did I get cancer? There's another way to actually address that question, which is, how come we don't get cancer more often? Why don't children get cancer more often? How come young adults don't get cancer more often? The remarkable thing that I've come to realize is that, in fact, our body's defenses really are designed to actually help fight cancer. So, while we actually want to find ways to destroy cancer, supporting our body's own ability to resist cancer is incredibly important. And that's really what this food as medicine opportunity, I think, is really a adjunctive a direction that can complement. It's really a new approach to fighting cancer that's going to complement our best drug treatments. So, when I went to medical school, I had, probably less than a week worth of nutrition research, and many medical students have even less. I think only 20% of medical schools require any type of coursework in nutrition over the course of the 4 years of a doctor. And most doctors themselves don't necessarily eat very healthy in their own lives. And so not surprisingly, I think this is an area of medical education as well. Have a little bit of empathy, sympathy for your doctor if they don't actually have answers to your nutrition questions, but you have to find resources that you can actually trust. And that's one of the things that I try to write about in my book. Food isn't enough. Other things that can help, obviously, are regular exercise, which also boosts your body's health defenses. Sleep is important, and many people don't know that if you actually, the immune system has been studied, if you sleep at 65 degrees Fahrenheit, that's actually a temperature at which your immune system, which resets itself at night, seems to actually optimize its immunity. Your immune system is optimized for the next day if you actually sleep at 65 degrees. So sleep, stress reduction, exercise, a healthy diet, and getting the right medical treatments are all part of the entire, I would say, repertoire that we should go for. And I think those are all the questions that I've really hit upon. Anybody that wants to find more information from me, please, you can find me online at drdrwilliamleeli.com. drwilliamlee.com. You can follow me on social with my, at Dr. William Lee. My book, Eat to Beat Disease, is available anywhere books are sold. And, there's a lot of work that I'm actually doing in partnership with other organizations, and would love to be able to collaborate with the cholangiocarcinoma community to be able to help bring the element of nutrition as another tool to help fight cholangiocarcinoma. And so with that, I thank you very much for the opportunity to speak with you all today.